Now we'll move on to the next stuff we should be discussing, and this is the what the ACE. Okay, so this is the ACE. That's angiotensin converting enzyme. So for the angiotensin converting enzyme, you can have it here. Okay, you can see that what all these processes here. You can spot out the angiotensin converting enzyme there. That's to tell you that that is where it basically works. Okay, so let me see this. Oh, okay, that's too big. I think we'll be using this. So angiotensin converting enzyme, you should know that what is a key enzyme in that pathway that they call the RAS system. That's what renin, angiotensin, aldosterone system. So this system actually regulates blood pressure, fluid balance, and electrolytes, like balancing electrolytes. Do you understand? So it's found mainly in the lungs, in the kidneys, and endothelial cells. So it converts this angiotensin I into what? Angiotensin II, which is active. Angiotensin I will be converted to angiotensin II, which is more active. Okay? So angiotensin II effects, it helps to what? Constrict the blood vessels. It helps to stimulate aldosterone release from the adrenal glands. It helps to increase sodium and water retention. It helps to enhance sympathetic nervous system activity. Okay, so I think I've made a lot of progress. Okay, so this is angiotensin I to be converted to angiotensin II by this angiotensin converting enzyme that we're discussing. So these are all its effects. All of this is its effects. So biological role, renin release. Okay, that's like we're now going all through all this what process. So first is renin that is released. Renin becomes what? Sorry, renin converts what? Angiotensinogen, which is produced from the what? Liver, to be converted into what? Angiotensin I. So the angiotensin converting enzyme comes in now, converting the one to two. So angiotensin II now is the one that will now act on the blood vessels, adrenal glands, and kidneys, bringing about different effects that, in summary, is to regulate the blood pressure and fluid balance. So angiotensin converting enzyme also breaks down bradykinin, which is a vasodilator. So this will now make it that what nothing is making the blood vessels to dilate, but rather all the activities of the blood vessels is towards constriction. So clinical relevance in hypertension, it means that its activity is too much. So blood vessels are constricting too much. You know, do you understand? So they now do drugs that will block its activity, thereby reducing the blood pressure. Because if activity is high, the blood pressure will be high. Also in heart failure, angiotensin converting enzyme inhibitors reduce afterload and improve survival. So in diabetic neuropathy, angiotensin converting enzyme inhibitors will protect the kidney by reducing atrial pressure. So it forms a basis of making drugs. So have drugs that will actually inhibit its activity. So you use these drugs when the activities of the angiotensin converting enzyme is too much. So drugs like captopril, enalapril, lisinopril, ramipril. So benefit is to counter the effects of that one, thereby reducing the blood pressure, reducing the heart strain, and protecting kidneys. Disorders linked to it include if it is high, you have high blood pressure, heart failure. If it is low, the blood pressure is low. Do you understand? So that's what we have for angiotensin converting enzyme.